Binary operation. A binary operation on a set K is a rule called the law of composition, such as addition or multiplication, by which we combine two numbers of a set K to produce a unique third number. So in binary operation, it works on a set, where two numbers from that given set are combined to form another number. A basic binary operation is the arithmetic operation, and the arithmetic operation includes plus, minus, times, and divide. Now, let's consider the set of the natural numbers. The set of the natural numbers, which begins from 1 to infinity. 1, 2, 3, 4 to infinity. Now let's operate the set of natural numbers with the arithmetic operation. Now remember that binary operation involves taking two numbers from a given set, operating them together to form a unique number. Now let's take two numbers from the natural numbers. We can take a number like 2 and 5. So the two numbers we'll take from this set, they are 2 and 5. Now what is the binary operation here? Is plus, an arithmetic operation. And when we combine these two numbers together, we have a unique number, and that number is 7. Let's take another two number from there. We have 8 minus 3. Now 8 minus 3 are taken from the set of the natural numbers. And when we operate them together, we have a unique number, which is 5. Now, let's take another number again. 10 times 4. 10 times 4 gives us a unique third number, 40. And 25 divide 5 gives us 5. So, when dealing with the binary operation, it works on a set. It works on a given set where we combine two numbers to form a unique third number. But what we have done so far, we work with the arithmetic operation. Apart from the arithmetic operation, we have other operations which we'll consider. Now let's consider an example with an operation that is not an arithmetic operation. But the thing is, the given operation must be defined. So let this be example 1. Example 1. Consider the operation is given as star. Let's use star for this operation. Now, what is the function of star? Now, P star Q is equals to P minus Q all over P plus Q. Now the operation is defined. The operation star is given. You have to subtract both elements and divide it by the addition of both elements. Now, given this condition, evaluate A 2 star 5 and B 7 star 3. So since we already know what star stands for, it becomes easy. So to solve this, we just assume that 2 is P and 5 is Q. Now remember that P star Q is equals to P minus Q over P plus Q. So 2 star 5 will give us 2 minus 5 all over 2 5, and this gives us minus 3 all over 7. So minus 3 over 7 is the answer. Now let's solve the other one, which is B. 7 star 5. 7 star 5 becomes 7 minus 5 all over 7 plus 5. And this gives us 2 all over 12, which is the same thing as 1 over 6. And this becomes the answer. So this given operation is defined as this. Now when we operate it together, we have a unique tiled number. Now let's consider example 2. In example 2, consider the operation so this operation is given with a symbol. It's a circle with a dot in it. A circle with a dot in it, such that A operation B is the minimum of A and B. Now evaluate. For operation 9, 11 operation, okay, the B is 11 operation 3. So let's get into it. The first one is for operation 9. Now remember that A operation B is equals to the minimum of A and B. So 4 operation 9 becomes the minimum of 4 and 9. And when we deal with minimum, means the smaller value. So become between 4 and 9, which of this value is smaller than the other one? And the smaller value is 4. 4 is the minimum between 4 and 9. Now solving for B, 11 operation 3 is the minimum of 11 and 3. So between 11 and 3, which one is the smallest? Of course, it's 3. So this operation is defined as the minimum between two numbers. And when we operate two numbers together, we have a unique tiled number. So let's move over to the next example. Example 3. Consider the operation this operation has a symbol that looks like a triangle. Now is defined as arrow triangle x is the absolute value of the difference of arrow and x. And this is the definition of the operation. Now evaluate A 1 operation 6 and B 9 operation 2. Now operation 2, okay, B is 9 operation 2. Now let's get into it. Now since arrow operation x is absolute value of the difference of arrow and x, then 1 operation 6 will be the absolute value of 1 minus 6, and this is the absolute value of minus 5, and of course absolute value of minus 5 is 5. The absolute value has to do with the positive part of the number. So whether it's minus or plus, just take out the positive part of it. Then for B, 9 operation 2 will give us absolute value of 9, difference 2, and this will be the absolute value of 7. Absolute value of 7 is 7. And that is the answer. Let's take another example. Example 4. Example 4. Consider the operation and the operation has a symbol that looks like equivalent. Okay. Now, such that P operation Q is equals to P minus Q all over PQ. And this is the definition. Hence, evaluate A2 operation 6 and B6 operation 2. So let's get into it. Now, since P operation Q is P minus Q over PQ, then for the A part 2 operation 6 will be what? 2 minus 6 over 2 times 6. And this gives us minus 4 over 12, which is the same thing as minus 1 over 3 when you divide both sides by 4. So for the B part, we have 6 operation 2, and 6 operation 2 will be 6 minus 2 all over 6 times 2, and this will give us 4 over 12, which is 1 over 3, and that is the answer. So when dealing with a binary operation, it has to do with a given set. It is defined on a given set such that two numbers or two elements from that set are combined together to form a unique element. If you want to learn more about binary operation, kindly message me on WhatsApp. You can ask me your question over there. I'm always there to answer you. Meanwhile, subscribe to this channel, like and share this video. I'll see you in my next video.